Hi everyone, in today's lesson we're going to talk more about the derivative with a little bit more harder examples. So using limit definition of the derivative, find dy dx, or f prime, means the same thing if f of x is this function. So the first thing that we're going to do is write down the definition. So we're going to take the limit as h approaches 0 of f of x plus h. So what that means is everywhere I see an x, I'm going to put an x plus h. So x plus h plus 1 over x plus h. All right, so we're going to make that our f of x plus h. Then minus our f of x, which is x plus 1 over x, all over h. Now, before we can take the limit as h approaches 0, we're going to have to do some algebra and simplify this expression. So we're going to need to make a common denominator. So this side is going to need an x plus h, and this side is going to need an x. So if we distribute the x in, and we double distribute this, let's see what we get. X squared plus xh plus x minus this times this. So if I do that work on the side, I'll get x squared plus xh plus x plus h. So x squared plus xh plus x plus h. So I just combined all this, and I'm going to put it over the common denominator. So all over x times x plus h. Now I can distribute this negative. So this will be x squared plus xh plus x minus x squared minus xh minus x minus h all over x plus h. So let's see what I can cancel out. The x squared and the negative x squared, the positive xh with the negative xh, the x and the negative x. So all I can simplify this to is negative h over x plus h, all over h, right? Because I was just simplifying the numerator, I still have this original over h. So we're going to keep, change, and flip. So we have negative h over x plus h. And if I want to flip this, it's times 1 over h. I can cross the h's off, and I'll be left with negative 1 over x plus h. So I now want to take the limit as h approaches 0. So now we're going to substitute 0 in. So I have negative 1 over x plus 0. So negative 1 over x is my derivative. So dy dx is equal to that. So if I want to find the derivative at x equals 4, all I'm going to do is plug in. So if I have dy dx, which is equal to negative 1 over x, all I'm going to do is plug in 4. So what is the derivative at x equals 4? Negative 1/4. Okay, let's see if we can try a different example. So again, we're going to start by writing the formula. So we have the limit as h approaches 0, and we need to find f of x plus h. So every time I see an x, I'm going to put an x plus h. So x plus h plus 5. So radical x plus h plus 5, that's f of x plus h, minus f of x all over h. And f of x is x plus 5. Now, before we can evaluate the limit as h approaches 0, we're going to have to simplify this using radicals. So we know that we can multiply the top by the conjugate. So we're going to change the middle sign and we're going to multiply this by the top and the bottom. So let's multiply the numerators. X plus h plus 5 under a radical times this radical, which is the same thing as squaring it, so we are just left with what is inside the radical. This times this will cancel with this times this, so we don't need to write that. And then we have a minus, because we have a negative times a positive, of this whole thing. Again, when you multiply a radical by the same thing, it just becomes what's left on the inside. All over h times radical x plus h plus 5 plus rad x plus 5. So let's see what I can simplify on the top. First, I'll distribute the negative 1. So I have x plus h plus 5 minus x minus 5 over h, x plus h plus 5 plus radical x plus 5. So x and negative x, 5 and negative 5. So I'm left with just h over h times this. And it looks as though I can cancel these out, and when I divide them I get 1. So now I want to take the limit as h approaches 0 of 1 over rad x plus h plus 5 plus rad x plus 5. So if I plug in 0, I will get 1 over rad x plus 5, because this is 0, that'll go away, plus rad x plus 5, which is 1 over 2 rad x plus 5. So this is my f prime of x. So they want to know what is the derivative at negative 2, 3. So all we care about is the x value. So at x equals negative 2, what is the derivative? So I'm going to plug in negative 2 into my derivative function. So you should get 1 over 2 times the square root of 3. That is the slope, or the derivative, at negative 2/3. Alright, let's see what's on the next page. Alright, so it is your turn now. This is your concept check. I want to see if you can do these two problems by yourself. So both of these are for homework, and don't worry if you struggle with this because we will go over it in class tomorrow, but I want to see that you've made an attempt. Alright, have a good night.